This is section 2.3 about reflections. So in our last sections, we've talked about translations, which are slides. So in a translation in which a shape just slides one direction, it can go, like in this case, to the right. So if we move point R from -4 to 1, that was 1, 2, 3, 4, 5 spots. So then we need to move T 5 spots. 1, 2, 3, 4, 5. So T is moved to 3, and we need to move S 5 spots. 1, 2, 3, 4, 5 to S. And that becomes our new point. So that would be R prime, T prime, and S prime. So to write prime, you just write the letter and then like a little apostrophe. So that is a translation, which is a slide, meaning it doesn't change any direction, just all the points move the same direction, the same number of units. A reflection, on the other hand, so we're going to erase all of that if we can. A reflection is going to be just like it is. It's a reflection over a certain axis. So if we reflect triangle TRS over the y-axis, T is going to be moved to 2, right? Because T is 1, 2 spots from the y-axis, and if we're reflecting it over that, if this is our axis of symmetry, then it's going to be 2 spots away from it on the other side. Think about it. R is 1, 2, 3, 4 away, so it's going to be 1, 2, 3, 4 away over here. And S is 1, 2, 3, 4 away, so it's going to be 1, 2, 3, 4 away over here. And this is our triangle. So whereas the slide was still facing the same direction as the original triangle, with the reflection, it is now an exact reflection. So it's just like a butterfly, like a butterfly's wings. If you fold it together, it's going to be matched up evenly. You can reflect things over more than just the x and y axes as well. So in this case, we have the line y equals x is the green line here. And if we reflect the triangle DEF over this axis, again, you want to think about if you rotated this, so it was like a butterfly's wings, and you wanted to be able to fold on this axis of symmetry, the y equals x line. That's just the equation of this green line, by the way. If you wanted to be able to fold it up so that it was matching, you would have to have a point here, right, to match up with, so that would be E prime. And then F is 2 down from that, right? F prime. And then D is 2 up from that, D prime, right? And if I draw that triangle, now those, if they folded along the line y equals x, which is the given axis of symmetry, then those would match up. So, like what? If you put this back this way. Likewise, if I had any line, I could say I wanted to flip this triangle DEF, which I'll erase what we had. If I wanted to flip DEF over the line x equals y equals -1, this line here, okay, that's y equals -1, and we're obviously later going to talk about equations of lines. If I wanted to reflect DEF over y equals -1, so then in this case y equals -1 would be my axis of symmetry. Well, think about it. I'm 2 away, E is 2 away, so on this side it needs to be 2 away, right? And there's E prime. E prime. And then D is 1, 2, 3, 4 away, so it needs to be 1, 2, 3, 4. It's going to be down here off my grid. D prime, right? And then F is 1, 2 away, so it needs to be 2 away on this side. So now it's reflected, and again, if you turned this, right, so that we're looking at our axis of symmetry right along here, there's our axis of symmetry, and if we folded it, the red triangle here and the green triangle here would match up like a butterfly's wings. Section 2.4 now, moving right along, is talking about when shapes are rotating. So this is our next transformation. So far we have translation, which is when they slide, reflection, which is when they reflect over an axis of symmetry, and now we are talking about rotations. So they rotate a certain degree measurement around a center of rotation. So this diagram here shows us, so if we think about the red angle, the red shape, it's rotating 90 degrees, right? Think about if you were facing a certain direction. So if you were facing this way, right? How far do you have to turn? Oops. How far do you turn to face now that direction? Well, think about it. This was your starting point, and now you're this way. What's that angle? 90 degrees, right? So degrees could tell us just how far we need to be turning. Undo all of that. So the blue is the image. It's the rotated image. Think about it when we're talking about degrees in a whole circle, right? How many degrees are in a circle? 360. So if something makes a full rotation, it rotates 360 degrees. If it, like this red one, if it rotates that on a straight line, it's 180 degrees, right? If it went from there to there, that's 3/4 of a circle, right? So then you can figure that out with the 360 degree knowledge of a full circle. So you can always figure out how far it's rotating based on the knowledge that there are 360 degrees in a full rotation. All right, that is all you guys need to know for class tomorrow. So I will give you a few practice problems now. Okay, the vertices of a triangle are 2, 3, 7, 4, and 6, 1. Rotate the triangle as described. Find the coordinates of the image. So for number 1, you just have 1 through 4. These are your only practice problems. Actually write out that it's asking you, write out this 90 degrees clockwise about the origin so that you know what you're doing when you look back on your notes. And write out all the points so that you know what points you're plotting. So these are 4 separate problems, so I need it on 4 different graphs. You can draw it on graph paper, which would be the best, and that's what I am asking you to do. But if you don't have graph paper, I understand for this assignment, and you can go ahead and draw your own graphs, and if they're not exact, it's okay. So you rotate it 90 degrees clockwise about the origin. That's the point 0, 0, right? So that's just like what we did in our example before, as if we were rotating that trapezoid about the origin. That's what you're going to do. And then 180 degrees about the origin, 90 degrees counterclockwise about the origin. So it's each of those points, plot them, and then every point, think about if I move to that 90 degrees, how far is it going to move? And you want to think about making a line between the origin and that point, and then the line between the reflected point and the origin, and that should create a 90-degree angle. All right, so see what you come up with, and I will see you in class.